So what's up everyone, and welcome back to the second part of this tutorial where we will be answering a bunch of questions regarding our region-based creation world. So let's go ahead and let me run the scene to show a couple of things. So here is what I've been up to. So I've been implementing the fog of war system back for this RTS now that we are not using physics. And the last hurdle I'm facing is how to enable the visibility of objects behind the fog of war system. So I'm thinking about using two solutions, which is a shader-based approach to gather information from the fog of war viewport texture, or I'm going to be checking by distance for that. So that is whenever it will be ready, I'll do an update on the fog of war system. So you can also have a nice pretty solution. And as well, I have implemented some other stuff like changing the mouse icon based on if the unit you're hovering your mouse is of another faction. So let me start by answering the first question here on my list. Also, there's something else I want to comment before we start. So this tutorial will not be from scratch like I do most of my tutorials. And that is because, I thought that I'd rather, instead of try to recode everything from scratch just so you can follow along, I will be much better if I just answer the questions and show you and explain how that works. So I think that's going to provide you more information based on the time. Otherwise, this would need to be a lot of more parts. And frankly, I want to get this ball rolling so I can finish this project and we can move on to other and better things. So having said that, there's a lot of shit here that I got to talk about. So let's start with the first question. How do you create a dictionary data for each part of the map piece? And as you can see, each part of the terrain holds a cell of the map, and we need to create a region system that is going to act like a grid system, so we can actually work it out with information like objects inside of it and other stuff. So the structure for that I built inside a module, which I call RTS world. And let's see what this is all about. So I have some stuff here. And the code that creates and generates the regions code, the grid system region for each of those mesh pieces is actually right here. So here's how it works. Whenever we start our map here, I have the main mesh here, which is our world 3D, which basically holds everything together here. And it has a script which is called RTS map world. So for reference, that's it. It's a simple node 3D. And it has a RTS world, which is that module loaded here as a script. The variable that holds all the information for the regions inside my world comes from this variable here, which is a dictionary. On the ready function here is where I create and generate the region sections. So first I determine the grid size. Now the map grid size here is a variable, so I can hold the size of a single grid cell for the map, and also I need for the fog of war system the entire map size. So whenever we start, the first thing I'm going to be doing here to create the region sections is to start by grabbing the map grid size, which will be used to create the regions later. So from the module RTS world, I have a function called RTS world get grid size, which needs to access the map parts so it can create the grid size. So the navigation map 3 nodes here is just the children node of the navigation region 3D. So here on my scene, this is the main navigation region node that is going to hold the settings for all the navigation nodes we're going to be creating for each region. And inside of it, as a start, it has a node which we exported from Blender. And you can see here it holds each one of the parts that we have exported as the GLTF. So this is where it holds the actual mesh pieces for the map. So we need to access those mesh pieces, and that is cached here under navigation map parts 3 node, which is accessing the navigation region nodes and grabbing the children, which is this guy. But whenever we go to my ready function for the RTS world, we need to pass that navigation 3 node its children, which respectively means which means all the map parts inside that function for the module RTS world. So inside the code for the module RTS world, we have a couple of functions here. The one that is useful for this, the RTS world get grid size. So this is going to build a grid vector to I from the ABS size for the first map part. And here is actually AABB. I don't know why I typed ABS there. So it requests an array of nodes, which is returned for the get children from the RTS map world, which will contain an array list of all our map nodes. Then it's going to spit out a vector to I, which is going to be used as the RTS world grid size. So the grid size is created by grabbing the first map piece from the map mesh parts from the array of nodes as a mesh instance 3D, so we can get auto-completion code for the get AAB. So once we have the AAB, we can ask for its size, which basically returns a size from the position to the end. And this size is going to be used as the grid size. Now the region grid size is a conversion from the vector tree for a vector to I, which we'll be using as a top-down grid system. And if you wanted to have rectangle world sizes, you can, instead of using X for both of the values here, can use X and Z. So for you to update the system and allow you to have rectangle map. So I plan to have only square grid maps, so I'm not going to worry for that for now. So I'm going to be using X for both X and Y values here for the vector Y, and I just later returning this as grid size. This is going to allow us for our RTS map world to have a grid size for the terrain. So we already have the first piece of the puzzle, which is what is the size of a single grid cell for our region system, and that is grabbed from the AAB of the first map part. Okay, now we're going to jump right ahead and create our regions for the RTS world, and there's a lot of things happening inside of this function. From this RTS map world, what is getting out of this function is only the map size. So the map size is being assigned here from the RTS world from the function RTS create in regions. So there's a couple of arguments here. The first one is the world regions dictionary, which is where we'll be storing the structure for the regions dictionary. Second, we need the navigation map 3 node parts. So the navigation map 3 node is where we are storing every single piece of the map, just like on the previous function. So that is how we are going to pass them to be generated in the regions. We also need the map grid size, so we know the size of our regions is going to be. So that's why the first step was to create the grid size for the map. And the next one is a navigation map. So what I'm doing here with the navigation map as an argument is using its navigation mesh here. As you can see here, whenever you set up some settings here, I want to use these settings for each single of the map navigation nodes for each map piece. So for you to do that, instead of you setting these settings for each one of those regions, instead I create the navigation region node inside the editor, bake its navigation mesh with the settings that I want for the map to have, and I just copy these settings from the navigation mesh of this node to all the subnodes that are going to be generated for each terrain piece. So this allows me to get almost a preview of what the navigation will look like. So as you can see here, I have reduced the slope of the navigation mesh to avoid stepping over terrain that I don't want. So you can see here how that would look like. So places where I don't want the units to step in, I simply decrease the slope to 20 degrees so they stuck out of those areas. So this is stuff you have to adapt to the terrain you model on Blender and how you want your units to behave. Also, something that we will be setting through code is the minimum region size. So minimum region size is for you to avoid making smaller islands on places that we don't want our units to go. They are disconnected from the main mesh. So let's say that you give a back mesh here. You can see there are parts of the world that we don't want meshes to be built inside. And you can see disconnected triangles here. So we're not going to use that first because our units cannot get there. And secondly, because who wants to use an isolated piece of navigation? So we don't want that. So one of the ways you can fix that is by increasing the minimum size to a given value. Now this value will change depending on the region, the size you're going to be assigned for your world terrain. So here you can see the size, so the minimum size cannot exceed this area, otherwise it will not bake at all for each of one of those mesh pieces. So this is something I'm going to be setting through code here. But as you can see, the effect it has on this mesh here, just as a preview, set it to 260, and whenever we bake navigation, you can see the smaller triangles here we didn't want it are now gone. And we could increase this, but for now let's leave it at that. So basically what this means is you can set a lot of settings through here for a navigation mesh that's going to be applied for every single duplicate copy you are going to create for each region terrain here. So that is why I have the navigation region node set up to be added on here. So we are going to be grabbing navigation mesh from this navigation node here, so we can create our duplicate copies for the regions later. And finally, we also need a node to place our duplicated navigation regions. So instead of we adding it inside on the map part or somewhere place else, I decided to create a node to group together all the duplicated navigation nodes. So you can see here we have around the map parts around 81 parts starting from 0, and we're going to have respectively 81 navigation nodes duplicating the navigation mesh baked with different navigation mesh information inside of this node. So that's why we need to pass that inside of it. And if you don't remember, that is because modules work with the concept of static functions only, so everything we need to access outside of the function, we need to pass them as arguments. That's why it's everything here. So we have two nodes here that we'll be using later. So that is the stuff that you need to pass for your RTS map world. So then we can come here on our module RTS world, and we will be creating our RTS world regions. So as you can see, here are the arguments that we're going to be using, and we are going to be returning a vector to I, so we can assign as map size later. So let's see how you create the region nodes. So the first thing I'm going to be doing here is on the place where we'll be dropping our navigation node to be used as a reference for the settings for the navigation mesh copies, we are going to get its navigation mesh and clear it. And this is because we want to clear the navigation mesh before we duplicate. Otherwise, the navigation information you see right here, all those polygons are going to be duplicated together for each single part of the region map cell. And we don't want that. We want to rebake after we have finished it. So to avoid wasting time on this operation whenever we duplicate, to not duplicate the navigation mesh arrays, we want to simply clear before we are working with it. And this will be almost the same thing as you accessing the navigation region and clear the navigation mesh, just like that. But if you ever forget to clear the navigation mesh, I am doing it through code here. So that is the first operation here. Now this array here is an array of navigation regions 3D that we're going to be adding. So later we can ask for the first rebake of the map. So we want to generate navigation meshes for every single one of those regions, and we want to bake them inside the same function. So I just create an array here so I can reference it later after adding every duplicate of the navigation node inside of it. So that is what is going to be used for this. Next, I also want to be generating the map size to be used for the fog of war system later. So that is why it's right there. So this is the main iterator for the map parts. So for each single map mesh we have in our terrain, so for each single square we exported from Blender as a map part, we want to be iterating through them. The first one is we need to grab its AABB. We're going to be using a lot. So what even is the AABB that I mentioned a lot? It's simply the bounding box of the mesh that contains every single vertex that is inside of it. So if you search here on the script what is AABB, it's a 3D axis aligned bounding box. So it's just for you to have a container for the mesh, the visual array mesh that is inside of it stored. So we can do calculations based on its top down size to create our region grid system. So you can see how that will look like. That's why on Blender you had to make sure those pieces were equal. We don't have issues later with the grid system. So going back here to my model RTS world, we have a variable to grab the center of that box in coordinates, which will be used to calculating its position in the grid. So this is simply accessing the center of the bounding box for the map region piece. So the region variable here, which is a vector2y, comes from a function inside this module which grabs a position in the grid for a vector 3. And we are passing the center of the AABB and the region grid size to input as argument for this function. So this function here, it's very important and is the basis of this idea of creating a region grid system. So it simply is going to return a vector 2y from a vector 3. And I'm doubling down on this to generate it from a position from vector 2. So I can simply pass if I wanted a vector 2 position or a vector 3. So I have functions for that. So this function is just generating a new vector 2 with the x and z coordinates from the vector 3 from this function. So the function that actually returns the position in the grid, despite of the vector 2 or 3, is this one. So this is how I'm generated the entire grid for the region. And I did a lot of testing for this, and I found a lot of issues with converting vector 2 to vector 2y. So be very careful when you're working from them. You can see here that input function is vector 2 and we are returning in vector 2y. So that is why I told you to have precise coordinates when working with Blender for each single match, because this is the part where you can get bugs. And you can say, well, why even keep that as a vector 2y? Why not just keep it as a vector 2? And this will, I believe, will speed up the code execution, because vector 2 integer based is much more simpler than vector 2 floats, and is also going to improve accuracy because this is an integer, there's no float errors inside of it. So I decided to use vector 2y, but you could use vector 2 if you wanted. So this is how it works. If you never generated a grid from a given coordinate, this is how you do it. You first pass the position that does not belong to the grid to be divided by the grid size, and that value you rounded it up. So this is how you can generate a position inside a grid, by dividing it by the grid size. That is why we generated the grid size previously, because we are using this a lot with this function. So that is how it works. For each single map piece we have here, we are generated from its center AABB, position according to the grid based on its size. So somebody comments that I should not use a terrain to be centered around the 0, coordinates. And depending on the things you are doing, you could face issues with dealing with negative coordinates and etc. But if you plan to build enormous big worlds, like even open world games, and you don't want to risk of wasting performance because you decided to make your world only positive, so you can only grow positions towards positive infinity. Instead, by keeping it near on 0, you can get a lot more space to build your 3D world, like you see here. And also it keeps things simple by center everything on the center of your world. So that is why I decided to use negative and positive values as coordinate system for my terrain. So that is how we are generating the region for the coordinate system. So this is very important here. So now what I want is to calculate the map size based on the region. So the region is going to be a vector 2, so like 1, -1, 0, 1. And if the region X is equal to 0, I'm going to be increase my map size by a vector 2y with the AABB from top-down view converted to a vector 2y. So this map size will be used later to adjust the texture size for the fog of war system. So whenever the region belongs to 0, I am increasing the map size by the given size here. So the idea with that is, let's see here, and I'm going to clear my navigation mesh so you can see what I'm doing. So whenever we are iterating through this terrain piece by piece and building the grid system, I'm going to reach a point that I reach the coordinate system 0 for x. So whenever we hit one cell that belongs to X, I'm adding its size to calculate as the map size later. So we are going to be adding as a map size, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know I have 9 pieces on that belongs to X equal to 0. So because my terrain is square, I know that this is the width of the map and also the height. So if you wanted to calculate rectangle maps, you will need to do another check for positions like Y equals to 0. So that is how I'm calculating the map size. So I can stretch the fog of war texture on top of it later. So that is what this part of the code is doing. For every map part, we are calculating if its region belongs to 0 to increase the map size, which we're going to return at the end of the function here. So the RTS world can grab that as its map size, so it can use for the fog of war system. So that is how it's working. So now that you have that, we're going to be creating our navigation bake groups. So this starts to answer another problem you're going to face, which is how do you use navigation baking groups? So Godot allows you to bake navigation based on children, which is the default behavior if you set it up. You're going to see here on parsed geometry that is from mesh instances and from root node children. So basically from children that belongs to the root node of the navigation, so this guy here. We can also pass it up as other things here. And one of those is group explicit. So this is going to allow you to create a group inside Godot and pass it up as a string, and you're going to see why that is going to be an issue later. Be used to bake the navigation. So if I do that and bake the navigation is not going to work anymore because you have to generate the group for it to bake. So that is the behavior we want because we are going to be passing a group name for every single region as a string value converted from the vector to y, so we can use to rebake the navigation for each separate region that we want. So that is what this part of the code is generating. So we are creating a string to be used as a navigation baking group name, which comes from this function that is going to convert our region, which is a vector to integer based, to a string. And the function that does this is inside this module is the get navigation group name that I created. And this simply is going to take our vector x value, add it with its y value, convert it to a string, so it can work a little bit faster. Because I tried to use an integer based approach to generate 2 truncate values to create that, but it seems that group names in Godot only works with strings. So that is what we are getting from this function here. And on this part of the code here, we are adding our map mesh parts that we are iterating on the map mesh parts to the navigation group we will want. So this is the group that is going to be accessed later whenever we want to rebake the navigation mesh from the command of the navigation mesh region node. Next, we want to duplicate our navigation region node and create one for each single region instance. So we can access a single region and ask for a rebake instead of rebaking the entire map at once. So that is how I'm doing it. First, I'm generating a new navigation region node. Then I'm creating a new navigation mesh from the reference that I have inputted here from the navigation region node as argument for this function. And I'm grabbing its navigation mesh and creating a duplicate. So that is how we are doing. I'm accessing the navigation region node, accessing this navigation mesh resource here, which is going to hold all the settings for the navigation to be just like we did here. So the minimum size here is going to be the minimum size, which is the square calculation from the cells to be rebaked, so we don't waste time trying to bake separate isolated islands. So this is how I'm calculating for each region, which is basically a float copy of the region grid size. So we could increase this, but be mindful that if you increase that too big, you're going to run the risk that your square region is not going to hold enough size to be baked at all, and the navigation is going to simply skip that. So what I want to do is just to make sure it holds at least the x value for the region minimum size. Remember, this is a square value. Next, I want to set the navigation mesh baking method to be using navigation nodes groups. So this is the same thing as accessing the navigation region, accessing its navigation mesh, and telling it to bake using group explicit. So as you can see here, source geometry groups explicit. Next, after have set that up, we need to pass the name we're going to be using to bake stuff inside this region. I set it up from the navigation baking group name that we created here, which is basically the region value as vector2i converted to a string, which we're going to be using it here. So on this step here, for the navigation mesh, I'm adding it, setting the group here to be used the same group that we'll be using for our map mesh. So whenever we add buildings inside the given region, we also are going to be adding it to a group just like we added the map mesh. So whenever we ask for a rebake, the rebake operation respects it. So after we have created that, I'm going to be accessing the new node that I just created here and setting its navigation mesh to the duplicate copy we grabbed from the reference from the argument of the function, plus all of those changes here. And I'm going to be adding that region navigation node to the temporary array that I created here so I can rebake all of those regions later. And that is what this code is doing. Next, I'm going to be adding this navigation region node here inside my navigation nodes tree, which is going to be this guy right here. I'm going to be adding all of those duplicate copies for every single region that I created inside that node there as a children. This is how you do it, by calling the add child inside of that. So all of that just to take care of the navigation per region.